All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to start by multiplying the 4 by the 81 to remove it. And so you're going to have x squared minus 36x plus 324. And then the two numbers that you're going to want to use are 18 and 18. So we're going to have 4x minus 18 and then 4x minus 18. And then these will both reduce to 2x minus 9 and then 2x minus 9. And we can write that as 2x minus 9 squared. And so that would be your answer for the factoring. For the math knowledge question, we have a number line. And they tell us that A is at negative 5.5. And then B is 7.5 units away from that. What are the possible locations for B? Well, it could be this direction, 7.5. And so negative 5.5 plus 7.5 in the negative direction is going to be a negative 13. Or it could be going this direction. And so if we put it here, we would add 7.5 because we're going to the right. And so that would be a positive 2. And so negative 13 and positive 2 would be your answer. So we're looking at lesson 92 today, quadrilaterals on the coordinate plane. So hopefully after this lesson, you'll understand how to deal with quadrilaterals on the coordinate plane. So looking at an example, the vertices of our quadrilateral are given, and they want to know, is it a parallelogram? So the first thing that you need to do is to graph your vertices. So we're going to start by going over 1 and then up 6 for E. And then we're going to go over 5 and then up 7 for F. And then we're going to go over to 3 and then up 1 for G. And we're going to go over to 7 and up 2 for H. Then we're going to connect our sides. And so that's going to be our parallelogram, or that's our quadrilateral. And we want to figure out, is it a parallelogram? Well, we know that opposite sides of a parallelogram are parallel. So we need to find the slope from E to F. So we went up 1 and over 4. So the slope here is a 1 over 4. On the opposite side, the slope is also 1 over 4. So those two sides are parallel. For the slope from H to F, we're going to go up 1, 2, 3, 4, 5, and then go left 2. So the slope is negative 5 over 2. And then from G to E, we go up 5 and to the left 2. So that's again negative 5 over 2. These two sides are parallel. So is it a parallelogram? Yes. And the reasoning is because the opposite sides have the same slope. Make sure on your test that you explain briefly why you do think it is a parallelogram. Okay? Looking at the next example, the vertices are given. Is it a trapezoid? So the first thing you're going to do is to graph the vertices. So we're going to go over 1 and up 2. And we're going to go over 6 and up 5. We're going to go over 6 and up 1. And we're going to go over 4. And so this is going to be our quadrilateral. And for a trapezoid, we know that we have one pair of parallel sides. So if it's a trapezoid, then we should have one set of parallel sides. As you can tell here, this side and this side are clearly not parallel. One's a vertical line and one is not a vertical line. Now JK and ML, it's a little bit harder to tell if they're parallel. The slope from J to K, we're going to go up 1, 2, 3, and then over 1, 2, 3, 4, 5. So it has a slope of 3 over 5. This one has a slope of 1/2 because we went over 2. So is it a trapezoid? Well, are these two sides parallel? No, so it is not a trapezoid. And the reason is because it does not have one pair of parallel sides. Looking at the next example, are these quadrilaterals congruent? So the way that we figure out if they are congruent is to figure out the distance of each side. So if you look at the distance from J to K, that's a horizontal line, so 1, 2, 3, 4. The distance is 4. Now for the other three, we can either use the distance formula or Pythagorean theorem, whichever one you want. I'm going to do the distance formula for one, and then I'll do Pythagorean theorem for the others. So we're going to do J to M. So we're going to do the square root of -6 minus a -5 squared plus 2 minus 4 squared. So -6 plus 5 is -1, and if you square that, that's a 1. And then 2 minus 4 is -2, squared is a 4. So the distance there is a square root of 5. Okay, now on M to L, I'm going to use this little triangle here. And it's a right triangle. And I'm going to be looking for the hypotenuse here. And so I can do 1 for this length, and then 1, 2, 3, 4. So 1 squared is 1, 4 squared is 16. So the square root of that would be the square root of 17. So this would be the square root of 17. For this one, I can use either the distance formula or Pythagorean theorem, whichever one you want. Either way, you should get the square root of 10 for the length. Okay, so those are the sides for that quadrilateral. For the other quadrilateral, this distance is a 4. This one, if you use the distance formula or Pythagorean theorem, you're going to get the square root of 10. For this one, you're going to have the square root of 17. And then for this one, you're going to have the square root of 5. Okay, so are the quadrilaterals congruent? Yes, because we start with a 4, and then we go to square root of 5, square root of 17, and a square root of 10. We start with a 4, square root of 5, square root of 17, and square root of 10. Now, we went clockwise for this one on the right. We went counterclockwise for the one on the left. But once we started with the side length and we continued in a circle, then the sides matched up. So that means that it was turned and also it was flipped over. Okay, but those two quadrilaterals are congruent because the side lengths match up in order as you go around your figure. Looking at this next one, determine whether the plot of land shown is a parallelogram, a trapezoid, or neither. So we need to see, are the sides parallel or not? Well, going from S to P, our slope is up 2 and then over 3. Going from P to Q, we're going to go up 2 and over 3, so that's a -2 over 3. Going from R to Q, we're going to go up 2 and over 3. And then from R to S, up 2 and to the left 3, so -2 over 3. It is not a trapezoid because it has 2 sets of parallel sides. So it is a parallelogram. It's not neither, it is a parallelogram. And then it says, what other type of quadrilateral is it, if any? Well, if you'll notice, the diagonals meet at right angles, and so that means that it is a rhombus. Okay, it's not a rectangle or a square because the sides are not perpendicular. This slope here, 2/3 and -2/3, those are not perpendicular slopes, so this angle right here is not a right angle. But if this was 2/3 and this was -3 over 2, those would be perpendicular slopes, and so this would be a rectangle. And then if they had the same lengths on all the sides, then it would be a square. But since they are not, it's just a rhombus. All right, so let's see if y'all can do this practice problem. We want to prove it's a parallelogram by determining the slope of each side. Okay, so looking from E to D, we're going to go up 1, 2, 3, and then over 1, 2, 3, 4. So the slope is negative 3 over 4. From F to E, we're going to go up 1, 2, 3, 4, and over 2. So 4 over negative 2 is just negative 2. From F to C, we're going to go up 1, 2, 3, and then over 1, 2, 3, 4. So negative 3 over 4. And then from C to D, go up 1, 2, 3, 4, and then over 2. And if you divide that, it's going to give you a negative 2. So the slopes of the opposite sides are congruent, so that means that it is a parallelogram. This one said to prove that it is a parallelogram. So that means that it is a parallelogram, and you just have to prove how we know that it is. It's not going to be, no, it's not a parallelogram. If it says determine if it's a parallelogram, then that's where it may be a parallelogram or it may not. But if it says prove it is, then they are telling you it is a parallelogram. Now you just need to show the work to show that it is a parallelogram. Okay? Let's look at another one. Y'all try this one, and then I'll go over it. Is it a trapezoid? So this one could be a trapezoid or possibly not. We need to find the slope of the sides. We know that PS and QR are obviously not parallel just by looking at it. Measuring the slope of SR, we're going to go up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. So 4 over negative 6 would be negative 2 over 3. From Q to P, we're going to go up 1, 2, 3, 4, 5, 6, and we're going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 over negative 9, those both divide by 3, and so we have 2 over 3. So is this a trapezoid? Yes. And how do we know? They have a set of opposite parallel sides. So that's how we know it's a trapezoid. Looking at another practice problem. Y'all try this one, and then I'll go over it. It asks if the two quadrilaterals are congruent. So I'm going to start off by drawing the two. So that's J. And then K. L, and M. Okay. And then we have S, which is at 5, 3. And then T at 7, 2. U at 7, negative 2. And V is at 4, negative 1. So we need to figure out, are those congruent? So the easiest way to do that is to find the lengths of each side. K to L is a length of 4, and so is T to U. You just count those because they're vertical lines. From K to J, we can use Pythagorean theorem or the distance formula, but you're going to get the square root of 5. And then from S to T, you're also going to get the square root of 5. For J to M, you're going to end up with the square root of 17. And from V to S, you're going to end up with the square root of 17. And then from M to L, you're going to have the square root of 10. And you're going to have the square root of 10 for V to U. Okay, so these quadrilaterals are congruent because their side lengths are congruent. It's just shifted to the left 2 and down 2. So those are congruent quadrilaterals. Now this one says to determine if it's a parallelogram, a trapezoid, or neither. Well, looking at it, I can tell that it's not a parallelogram because KG and JH are not parallel, just by looking. But it is possible it's a trapezoid. Is JK parallel to HG? So this slope is 1, 2, 3 over 1, so a slope of 3. This slope is up 1, 2, 3, 4, 5, 6 over 2, so 6 over 2 is 3. These are parallel, so it is a trapezoid only. Okay? Looking at the challenge question, explain how two quadrilaterals with congruent sides can be figures that are not congruent. Support your answer mathematically and draw an example. So y'all try and think of an example, and then I'm going to show you one. All right, so we can have a figure that looks like a kite, where these sides are congruent. Okay, and then I'm going to actually use this one to help you see what you can do. You can take these, and if we flip it, I didn't make it 100%. Let's see. That's pretty close to a figure. So the side lengths are the same. I didn't shorten or lengthen them, I just turned them and flipped them. And so do you see how taking these sides here and then just flipping them down into here, making it a concave figure, would give an example where you have two quadrilaterals with congruent sides that are not congruent. So there's one example. You may have another one, but that's the one that I did. Okay, so your homework is 1 through 30. So you need to make sure that you do that tonight so that we can go over any questions you have tomorrow.